infinite mystery of space. Hello everyone, welcome back to Sleepy Theories. As you settle in for the night, I invite you to close your eyes and let your mind wander, far away from the worries and pressures of the day. Imagine, if you will, a vast, silent expanse stretching infinitely before you, beyond the walls of your room, past the flickering lights of the city, into the limitless skies above. Have you ever wondered about the nature of the space we see every night, the boundless universe? Does it ever end, or does it stretch on forever, beyond what we can comprehend? Tonight, as you listen to these words, I hope you'll not only find yourself pondering this great cosmic question, but also feel a gentle peace washing over you. We will journey together, slowly, calmly, through the science of space and time, helping you relax, soothe your mind, and drift into the world of dreams. This is your time to let go, to let the endless mystery of the universe calm the restless thoughts, ease the anxiety, and quiet the worries that may have followed you into the night. For thousands of years, humankind has looked up at the stars, asking the same question: does space end? But in all those years, with all the theories, all the research, the one thing we still cannot answer is whether there is a boundary to the universe, or if it is, in fact, infinite. As we sit under the night sky, we wonder, are we looking at the very edge of everything, or are we merely glimpsing a small corner of something far grander, far more expansive than we could ever imagine? Tonight, as we explore this mystery, we will take a deep breath and consider the vastness of it all, not just as a puzzle to be solved, but as a journey, one that brings us closer to understanding ourselves and to relaxing into the infinite possibilities of the universe. For as Albert Einstein once said, the important thing is not to stop questioning. Curiosity has its own reason for existing. And so tonight, we invite you to simply question, to wonder, and to let your mind relax into the vast unknown. Perhaps you've come to this moment, listening, seeking peace. Maybe the weight of the day has followed you here, feelings of stress, anxiety, or even depression that linger in the mind as the hours pass. Know this: the universe, in all its endless wonder, can be a mirror, reflecting back to us our own potential for peace. Our search for answers, whether in space or in the depths of our emotions, is not always about finding immediate solutions. Sometimes it's about embracing the mystery, allowing ourselves to float in the calm of uncertainty. Much like the infinite expanse of space, the answers may never be fully clear, but the journey itself can be soothing. As Carl Sagan once said, somewhere, something incredible is waiting to be known. And in the quiet exploration of that vast somewhere, we may find the comfort we seek. Let this moment be a reminder to you that it's okay not to have all the answers. It's okay to be at peace with the unknown. Just as we don't yet know if space has an end, you don't need to have all the answers to your questions right now. This video is not just about exploring space. It's also about exploring the space within, taking a moment to breathe deeply, letting go of the tension, and opening yourself to relaxation. By the end of our journey tonight, I hope that, while your mind contemplates the boundless questions of the universe, your body will feel lighter, your thoughts slower, and you will feel ready to drift into peaceful sleep as the endlessness of the cosmos calms the restless mind. As the poet Rumi wrote, the quieter you become, the more you are able to hear. And in this quiet space of reflection, may you find your own answer to the question, does space end? Or is it an endless mystery we are only beginning to understand? So, take a deep breath, settle into the comfort of this moment. Let the soft rhythm of my voice guide you as we embark on a journey through the vastness of space. You are not alone in this exploration. and you do not need to carry the weight of the world with you tonight. Leave behind the stress, the worries, and the unanswered questions of the day. In the next few moments, let yourself float gently into the quiet expanse of the cosmos. Just as the universe unfolds infinitely, let your mind unfold, slowly, gently, letting go. As we dive deeper into this great mystery, feel your body relax, your mind relax, and let the soothing rhythm of our exploration carry you toward a place of peace. Let's begin as we ask, does space end? The origins of the universe. As we begin our journey, we must first travel back to the very beginning, the origin of everything. When we think of space, we often imagine the stars, the planets, the galaxies. But before any of this existed, there was nothing, only a singularity, an infinitely small point of pure energy and potential. It was from this singularity that everything we know today began to unfold, almost 14 billion years ago. The event we call the Big Bang was not an explosion in space, but rather the expansion of space itself. In the words of Carl Sagan, the cosmos is within us. We are made of star stuff, and in that star stuff, the very fabric of the universe began to stretch out, giving birth to galaxies, stars, and eventually to us. The Big Bang Theory, which remains the most widely accepted explanation for the birth of the universe, suggests that all of space and time began as an infinitely dense and hot point. This moment, known as the singularity, was not a bang in the sense of a loud noise. Rather, it was an expansion so rapid that it stretched space itself. This expansion, called cosmic inflation, occurred in less than a fraction of a second, during which the universe grew exponentially from something smaller than an atom to nearly the size of our current observable universe. Imagine that. In an instant, the very universe we live in began to unfold in a dramatic burst of energy. As the physicist Stephen Hawking once said, the universe does not have a beginning, but a time before time. But how did all this energy and matter come into being? What came before the Big Bang? This is where science starts to approach the boundaries of what we can understand. Before the Big Bang, there was no space, no time. In fact, according to Einstein's theory of relativity, space and time themselves are intertwined. They are part of the same fabric. One cannot exist without the other. When we talk about the beginning of the universe, we are not talking about the start of a specific point in time, but rather the beginning of time itself. As Hawking once said, time and space are finite but unbounded. The very concepts we use to measure and understand the world around us began their existence in that moment of expansion. The origins of the universe have fascinated humankind for centuries. For ancient civilizations, the idea of creation was often tied to mythology. Gods shaped the heavens, the earth, and the stars. In ancient Egypt, the universe was created from a dark, endless ocean where the sun god Ra emerged. In Greece, philosophers like Aristotle believed that the universe had always existed in a form that was both eternal and perfect. But as we advanced in our understanding, we turned to science for answers. The Big Bang Theory, as radical as it seemed, was a revolutionary shift in our understanding of the universe's origins, and it continues to shape our search for answers today. As the astronomer Sir Arthur Eddington put it, the universe is not only stranger than we imagine, it is stranger than we can imagine. As we look deeper into the history of the universe's birth, we find that it was not a smooth journey. The first few minutes after the Big Bang were some of the most important. This period, known as the early universe, was a time when energy and matter began to cool and form. It was during this time that the first elements, hydrogen and helium, formed, and the universe began to take shape. Gradually, galaxies and stars began to form from clouds of gas and dust. These early structures were the first seeds of what would grow into the vast and beautiful universe we observe today. The universe is not a thing, but a process, an event, said philosopher Alfred North Whitehead. And indeed, the universe's creation is a process that continues even now in every star and galaxy. But the birth of the universe also brings us to another deep mystery. What caused the Big Bang? What sparked this incredible, unfathomable explosion of energy? We don't know. Some theories suggest that the universe may have been born from a quantum fluctuation in a vacuum, a spontaneous and unpredictable event that caused a rapid expansion. Others speculate that the universe could be part of a multiverse, an infinite number of universes existing side by side, each with different physical laws and histories. The possibilities are as infinite as the universe itself. As the poet T.S. Eliot once wrote, "Only those who will risk going too far can possibly find out how far one can go." And it is in exploring the origins of the universe that we may one day find the answer, the observable universe, what we can see. As we continue our journey through the cosmos, we must first ask ourselves a simple yet profound question. What is it that we can actually see? When we gaze up at the night sky, we witness countless stars twinkling across a vast expanse. But the reality is, we can only observe a small fraction of what is truly out there. Our eyes, our instruments, and our understanding of space all have limitations. The observable universe is everything we can see, measure, or detect from our vantage point on Earth. And yet, this visible slice of the cosmos is vast, incomprehensible, and awe-inspiring. As the great astronomer Carl Sagan once said, "The cosmos is within us. We are made of star stuff. But how much of that star stuff can we truly see?" The observable universe, as the name suggests, refers to that part of the universe that is within our view. However, even the most advanced telescopes cannot see everything. This is because light travels at a finite speed, and the universe is constantly expanding. The farthest we can see is limited by the time it takes light to reach us. Light from distant stars and galaxies may have started its journey billions of years ago, but only now are we able to detect it. The farther away something is, the longer it takes its light to reach us. So, when we look up at the night sky, we are looking not just across space, but through time. As Sagan reminded us, the universe is a pretty big place. If it's just us, seems like an awful waste of space. One of the most fascinating aspects of the observable universe is the concept of the cosmic horizon. The cosmic horizon is the farthest distance from which light has had time to reach us since the beginning of the universe. Beyond this horizon, there is no information, no light, no signals, no matter that we can detect. As space itself is expanding, distant galaxies are moving away from us faster than the speed of light, making them effectively unreachable. So, while we may never be able to observe the entirety of the universe, the observable universe represents a slice, a small window through which we can view the grand story of existence. As the philosopher Albert Einstein once said, "The most incomprehensible thing about the universe is that it is comprehensible. But what about the limits of what we can see? How far does the observable universe truly stretch?" When we observe the sky, we're not just seeing stars, but galaxies. And these galaxies, in turn, are part of clusters and superclusters. In fact, the observable universe is made up of billions of galaxies, each containing billions of stars. Some of these galaxies are so distant that their light has been traveling for nearly 13.8 billion years, almost as old as the universe itself. Yet, even with the power of our most advanced telescopes, there's still so much that remains unseen. As much as we may know, the universe is filled with mysteries beyond our current grasp. Not only is the universe stranger than we imagine, it is stranger than we can imagine, said Sir Arthur Eddington. Now consider the vastness of the observable universe. It is almost too much for the human mind to comprehend. The most distant objects we can see with the help of instruments like the Hubble Space Telescope are galaxies located over 13 billion light-years away. And yet, this is just a small fraction of what exists in the universe. Beyond our cosmic horizon, there may be countless other galaxies, stars, and worlds completely invisible to us. As our technology advances, we may find new ways to peer deeper into the universe. But for now, we are limited by the horizon of light, a boundary that defines what we can know. We are not only the creatures who contemplate the universe, we are the universe contemplating itself, as Carl Sagan beautifully put it. But even though we can only see a small part of the universe, this knowledge is still profoundly beautiful. The stars and galaxies we observe are not simply dots on a distant canvas. They are the building blocks of everything we know. Every star is a potential birthplace for planets, including the possibility of life. Every galaxy holds the history of billions of years of cosmic evolution. By studying the observable universe, we are learning more about the fundamental forces that shape space and time. It reminds us of how small we are in the grand scale of things, yet how deeply connected we are to the stars. The cosmos is within us, Sagan said again. We are made of star stuff, and we are all part of this vast, endless web of existence, the infinite universe. What does infinity mean? As we continue our journey, we come to a concept that is as ancient as humanity itself. The idea of infinity, something that is without limits, without end. It is a concept that has fascinated philosophers, mathematicians, and scientists for millennia. When we speak of space, we are inevitably speaking of something that stretches beyond all comprehension, beyond the edge of our observable universe, beyond the furthest galaxies we can see. What lies ahead? Is there truly an end, or does space stretch on forever? This idea of infinite space has captivated human imagination since the days of the ancient Greeks, and it continues to challenge our minds today. As the great physicist Albert Einstein once said, "The most incomprehensible thing about the universe is that it is comprehensible." But what does infinity truly mean in the context of the universe? For most of us, infinity is more of an abstract concept, a number with no end. But when applied to space, infinity takes on a new, almost tangible form. Space itself, in theory, could stretch infinitely in all directions, with no boundaries, no edge. Imagine standing at the edge of space, looking out into the endless vastness, and realizing there is nothing beyond it. That beyond is not another universe or boundary, but simply more space, an infinite continuation. This concept is difficult to wrap our minds around, but it challenges the very limits of human understanding. As Blaise Pascal wrote, "The eternal silence of these infinite spaces frightens me." And yet, it is this very infinity that makes the universe so awe-inspiring. Infinity in mathematics is often represented by a symbol that we all recognize, a sideways 8 or the lemniscate. But this simple symbol holds so much more than just a mathematical value. It represents the concept of something that cannot be measured, cannot be contained. It is an idea that has been explored in countless ways, from the abstract infinity of numbers to the infinite vastness of space. Mathematicians have grappled with the question of infinity for centuries, attempting to quantify it, to understand it. But the more we try to define it, the more elusive it becomes. As the philosopher Immanuel Kant said, "The more the universe seems comprehensible, the more it also seems pointless." Perhaps it is this very infinity that prevents us from fully understanding our place within the universe. One of the most important aspects of infinity is the fact that it has no boundaries, no edges. And when we apply this to the universe, we begin to understand that the idea of a limit to space may be an illusion. Our minds are conditioned to think in terms of boundaries, of beginning and end. But if the universe is infinite, it has no beginning and no end. The very notion of an end is something we have created in our minds, a concept that is tied to our understanding of time and space. In the context of space, infinity means that no matter how far we travel, there will always be more to explore, more to discover, more stars to see. As the poet Rainer Maria Rilke said, the future enters into us in order to transform itself in us long before it happens. And perhaps the future of space is simply more infinity. But if space is infinite, what does that mean for our understanding of the universe? Can we truly comprehend something without limits? In some ways, infinity makes the universe feel both incredibly vast and yet oddly intimate. If the universe has no edge, no boundary, then perhaps the very question of where does space end becomes irrelevant. The universe is not just a place, it is a process, a never-ending unfolding of events. A place where galaxies are born, where stars live and die, where black holes grow, and where time itself stretches and bends. This perspective makes the universe seem alive, constantly evolving and expanding. As Carl Sagan famously said, "The cosmos is within us. We are made of star stuff, the universe, and we are inseparable in this infinite journey." But there are, of course, competing theories. Some scientists propose that the universe is not infinite, but rather finite. According to some models, the universe might be shaped like a sphere, and if you traveled far enough in one direction, you would eventually return to where you started. This idea suggests that while space may feel infinite to us, it could, in fact, loop back on itself in a way we cannot yet fully understand. This model of a finite but unbounded universe challenges the concept of infinity, suggesting that the universe could be both finite in its structure, but infinite in its possibilities. It's a paradox, one that we may never truly solve, but can continue to explore with wonder. As the poet John Keats wrote, "A thing of beauty is a joy forever." And perhaps the search for answers to infinity is a beauty in itself. So, what does infinity mean for us as humans? If space is infinite, then our place in it is ever-changing, ever-evolving. We are small, fragile beings living on a tiny speck in an immense, boundless universe. But in our smallness, there is also beauty. Our capacity to think, to dream, and to explore is what makes us significant in this infinite universe. And so, perhaps the real question is not whether space ends, but how we, as human beings, respond to the vastness and the mystery that surrounds us. As the famous poet Walt Whitman once wrote, "I am large, I contain multitudes." In the infinite universe, each of us carries within us a universe of thoughts, dreams, and possibilities, all of which are worthy of exploring. The shape of the universe. As we journey deeper into the cosmos, we now turn our attention to an equally intriguing question. What shape is the universe? Most of us imagine space as a vast, unending expanse, stretching in all directions without end. But when we consider the shape of the universe, things become much more complex. Scientists have spent centuries trying to understand the geometry of space, and the answers are not always as simple as they seem. For a long time, the prevailing view was that the universe is flat, like a sheet of paper, infinite in all directions. But as we peer into the depths of space, the evidence begins to suggest something much more intricate. The most incomprehensible thing about the universe is that it is comprehensible, Albert Einstein once said. And it is this very comprehensibility that we are trying to grasp. One of the most compelling ideas about the shape of the universe is that it could be flat, like a two-dimensional plane. This model suggests that if you travel in one direction long enough, you would never encounter an edge or a boundary, just more space stretching out ahead. But what if this idea of a flat universe is too simplistic? What if the universe is not flat, but curved in some way? There are two possible models for a curved universe. One that is spherical, like the surface of a balloon, and another that is hyperbolic, like a saddle. In the spherical model, if you travel far enough in one direction, you would eventually come back to where you started. It's as if the universe loops back in on itself, with no edge, but rather a continuous, unbroken surface. As the philosopher and mathematician René Descartes said, the preservation of order in the universe is the first cause of all things. And perhaps the shape of the universe is part of that order. To understand these concepts, we must think in terms of higher dimensions, beyond the three we experience every day. Space itself is not just flat or curved within the three dimensions we can see, but may actually exist within a higher dimensional framework. According to the theory of general relativity, mass and energy can curve the fabric of space-time itself. This curvature is what gives rise to the concept of gravity, and it might also explain how the universe could bend in ways we cannot perceive directly. For example, just as the Earth is a sphere, and we experience it as flat, the universe might also appear flat to us in our limited view. But on a grander scale, it could be curved in a way that we cannot yet fully understand. As Carl Sagan beautifully said, we are made of star stuff. We are a way for the cosmos to know itself. And in this way, the shape of the universe is part of that cosmic knowledge, a mystery to unfold. One of the most profound implications of a curved universe is that it might have no edge, no boundary. This concept challenges the way we think about the universe as something with a beginning and an end. If the universe is finite but unbounded, it means that it doesn't have a clear-cut edge or limit. Instead, space itself could be curved in such a way that the universe has no end, but rather a continuous loop, much like the surface of the Earth. If you travel far enough in one direction, you would eventually end up right where you started. This is a truly mind-bending concept, as it suggests that the universe has no outer limits, no final frontier. It simply keeps going, looping back on itself. And yet, we can't quite perceive it. As philosopher and physicist John Archibald Wheeler said, "We live in a world in which the more we know, the less we understand." And perhaps this is true of the universe as well. But even as we consider the possibility of a finite yet unbounded universe, another theory proposes something entirely different: an infinite, flat universe. In this model, space would extend endlessly in all directions, without any curvature at all. This idea is supported by recent observations of the cosmic microwave background radiation, which suggests that the universe is flat to a very high degree of precision. If the universe is indeed flat, it would mean that space itself is not curved or warped in any way, but instead continues on forever, stretching outward indefinitely. This model suggests that there is no edge to the universe, no final limit, just an unending, ever-expanding space. As Stephen Hawking eloquently put it, the universe doesn't have a place for a beginning or an end. It just is. There is also the idea that the shape of the universe might not be one of simple curvature, but could be a complex combination of curvature and flatness, creating a kind of multi-dimensional structure. This would allow for the possibility of different pockets or regions of space with different geometric properties, all existing within the larger universe. Such a model challenges our conventional understanding of space, suggesting that space itself could be more like a living, breathing organism, constantly shifting and changing. Some scientists even speculate that the universe could be shaped like a multi-dimensional object that we simply cannot perceive from our limited three-dimensional perspective. And yet, the mystery of this shape remains unsolved, like the question of what lies beyond the edge of space itself. As the poet Rainer Maria Rilke said, "The future enters into us in order to transform itself in us long before it happens." Perhaps the shape of the universe is something that will transform our understanding, not just of space, but of the very nature of existence itself. The end of space, a place or a concept. As we drift further into the mysteries of the universe, we come to a question that has intrigued humanity for millennia. Does space have an end? Is there a boundary beyond which nothing exists? Or is space infinite, stretching out forever with no limit, no edge? For centuries, philosophers, scientists, and dreamers have pondered this question, yet no clear answer has emerged. Today, we will explore this profound mystery together, contemplating whether space itself has a boundary or whether it is an endless, uncontainable expanse. "The universe is under no obligation to make sense to you," said Neil deGrasse Tyson. And perhaps that's part of the wonder of it all. Space doesn't owe us answers, only the invitation to explore. To begin, let's consider the possibility that space has an end, a physical boundary or limit. If this is the case, what would lie beyond it? In many ways, this idea challenges the very definition of space as we understand it. We imagine space as something that can be measured, something that extends outward in all directions, infinitely. But if space has a limit, then it must be contained within something larger, something beyond. Perhaps a mysterious edge exists, but to comprehend it, we would have to move beyond the confines of the universe itself. As the physicist John Archibald Wheeler once said, "We live in a world in which the more we know, the less we understand." And so, we find ourselves confronted with the mystery of space's boundary, unsure of what lies beyond it. On the other hand, there is the possibility that space is infinite, stretching on forever, without end or boundary. This concept, while difficult to grasp, offers a radically different view of the universe. If space is infinite, there is no edge, no final frontier. Space simply continues, wrapping around itself, never ending. Imagine standing at the edge of the universe, only to realize that there is no edge at all. Instead, there is just more space, more stars, more galaxies, more mysteries. As we continue to expand our understanding of the universe, the idea of an infinite space feels more plausible, more comfortable. As the philosopher and scientist Albert Einstein said, "The most incomprehensible thing about the universe is that it is comprehensible." And perhaps this incomprehensible nature of infinity is what gives it its beauty. The question of whether space has an end is closely tied to the larger concept of the universe's shape. In earlier keynotes, we explored the idea of a curved universe, one that could potentially loop back on itself, much like the surface of a sphere. In this model, if you traveled far enough in one direction, you would eventually return to where you started, never encountering a boundary. This kind of finite but unbounded universe challenges our traditional ideas of an edge. It suggests that space is not limited by a physical boundary, but rather by the nature of its shape. Such a universe would have no clear-cut end, only a continuous flow of space stretching out in all directions. As the poet Rainer Maria Rilke once wrote, "The future enters into us in order to transform itself in us, long before it happens." And perhaps the universe itself is part of this transformation, endless, unfolding. But even with these mind-bending theories, the question remains, can space truly have no end? Some models suggest that space could indeed be infinite, but in a different way than we imagine. Perhaps there is no edge to the universe, but instead, the universe is expanding faster than light, beyond our current reach. If space is expanding at such a rate, how can we know where it ends, or if it ends at all? As the universe continues to grow, the very fabric of space itself stretches, carrying galaxies farther away from us, faster than we can observe. This constant expansion could mean that the universe is in a perpetual state of flux, with no final destination, no final boundary. As the renowned physicist Stephen Hawking once said, the universe is expanding at an ever-increasing rate, and it's going to continue doing so for the foreseeable future. Perhaps the end of space is not something we will ever experience because space itself is constantly evolving. If we accept the idea that space may be infinite, it forces us to confront even deeper questions. What would it mean for the universe to have no end, to be infinitely large? Would our understanding of space and time change? How would this affect our place in the cosmos? These questions are both humbling and inspiring, because in an infinite universe, there is always more to discover, more to learn. It challenges the boundaries of our understanding and opens our minds to the possibility that the universe has no limits. As we contemplate the infinite nature of space, we are reminded of the words of the philosopher Blaise Pascal. The eternal silence of these infinite spaces frightens me. And yet, it is this very silence, this vast mystery, that calls us to explore, to wonder, and to seek answers. In the end, the question of whether space has an end may be one we can never fully answer. Whether space is infinite or finite, we are still left with the same awe, the same sense of wonder, as we gaze into the night sky. Space is not simply a place, it is a concept, a vast ocean of mystery that stretches beyond our understanding. But perhaps that is the beauty of it. Space is both a physical place and a concept that challenges us to think beyond the limits of what we know. The end of space, if it exists, may simply be the beginning of something even more profound, something beyond our comprehension. As the poet Walt Whitman wrote, "I am large, I contain multitudes." And perhaps the universe is like that too, an endless multitude of possibilities, ever expanding, ever inviting us to explore its infinite depths. Theories on the end of the universe. As we continue our exploration of space, we must also confront an inevitable question. What happens at the end of the universe? While it may seem like a distant and abstract concern, the end of the universe is a question that has preoccupied scientists, philosophers, and dreamers alike for centuries. Is there an ultimate conclusion to this great cosmic story? Or will the universe continue to expand forever, stretching beyond our ability to comprehend? Theories abound, each one more fascinating than the last. As the renowned physicist Stephen Hawking once said, the universe doesn't have a place for a beginning or an end, it just is. But still, the search for the ultimate fate of the universe is one of the most profound questions of our time. One of the most widely discussed theories about the end of the universe is the Big Crunch. The Big Crunch is the idea that the universe, after expanding for billions of years, will eventually stop and begin to collapse in on itself. This contraction would lead to everything being pulled back into a singularity, just as the universe began. The theory suggests that in the far distant future, the universe might collapse, and all matter and energy would be compressed into an infinitely small point, just as it was before the Big Bang. This dramatic end would mark the conclusion of the universe's existence, but it would also be a return to the beginning. In some ways, this theory seems to echo the cyclical nature of life itself. As the philosopher Heraclitus once said, "Everything flows, nothing stands still," and perhaps the universe, like life, is on an eternal cycle. But the Big Crunch isn't the only theory about the end of the universe. Another possibility is the Big Freeze. According to this theory, the universe's expansion will continue indefinitely, causing galaxies, stars, and eventually even atoms to drift farther and farther apart. As this expansion accelerates, the universe will grow colder and colder, and eventually all the stars will burn out. The universe will reach a state of maximum entropy, a place where nothing happens and nothing changes, and all that remains is a dark, empty, frozen void. In this view, the end of the universe is not a fiery collapse, but a slow, cold, and quiet fade into nothingness. As the famous astronomer Sir Arthur Eddington once said, "The universe is not only stranger than we imagine, it is stranger than we can imagine." Perhaps this strange end, quiet and distant, is the universe's final mysterious form. Another fascinating theory about the universe's fate is the Big Rip. This theory suggests that the universe's accelerated expansion could eventually tear apart everything, from galaxies to atoms. As dark energy continues to stretch space itself, the force of this expansion could become so intense that it overpowers the gravitational forces holding galaxies, stars, planets, and even molecules together. In this scenario, the universe would gradually disintegrate, ultimately leading to a catastrophic end, where everything is ripped apart at the atomic level. The Big Rip, though terrifying, provides a vision of the universe's end that is both dramatic and final. As the philosopher Friedrich Nietzsche once said, "He who fights with monsters should be careful lest he thereby become a monster." And perhaps, in the end, the universe will fight against its own existence. But the Big Freeze, Big Crunch, and Big Rip are not the only potential endings. There are other theories that suggest the end of the universe could be a much more complex, unpredictable event. Some scientists suggest that the universe could undergo a phase transition, changing from one state of being to another in a way we cannot yet comprehend. Perhaps the very fabric of space-time itself could shift, leading to a new era of cosmic existence. Some even propose that the universe could collapse into a new singularity and then expand again in a new Big Bang, a theory that would imply an eternal cycle of birth and rebirth for the universe. The possibilities are as vast as the universe itself, and no theory is fully conclusive. As the physicist Richard Feynman once said, "I learned very early the difference between knowing the name of something and knowing something." And in the case of the universe's end, perhaps we are only at the beginning of understanding. While all these theories offer different visions of the universe's end, they share a common theme: change. The universe is not a static entity, but a dynamic, evolving system. Whether it fades into nothingness, collapses into itself, or transforms into something entirely new, the universe will eventually reach its final state. But perhaps, even in its end, the universe will continue to inspire awe and wonder. The possibility of multiple endings, each one more mysterious and unknowable than the last, is a reminder of the vastness and complexity of the cosmos. It challenges us to think about our place in the universe, our brief moment in time, and what it means to exist in this ever-changing world. As the poet John Keats once wrote, "A thing of beauty is a joy forever," and perhaps the beauty of the universe is not just in its beginning, but in its endless transformation, the infinite expanding universe. As we move deeper into our journey through space, we encounter a concept that both fascinates and perplexes us: the idea of an expanding universe. From the moment we first observed the stars and galaxies, we have known that space is not static. It is constantly in motion, stretching and growing. But what does it mean for the universe to expand? And how does this expansion affect our understanding of space and time? Imagine, if you will, the universe as a balloon. When inflated, every point on the surface moves farther apart. Similarly, space itself is expanding, with galaxies drifting away from one another. The expansion of the universe is a process that is ongoing, constant, and ever-changing. As the famous cosmologist Edwin Hubble once said, the velocity of recession is proportional to distance. And in this simple yet profound observation, we begin to understand the vastness of the universe's expansion. To comprehend this expansion, we must first consider the idea that space itself is stretching, not just the objects within it. This concept, first introduced by the American physicist Edwin Hubble in the 1920s, revealed that distant galaxies were moving away from us at speeds proportional to their distance. In other words, the farther away a galaxy is, the faster it appears to be moving away. This observation led to the realization that the universe itself is expanding, and that this expansion has been occurring since the beginning of time. The concept of an expanding universe shatters the traditional view of a static, unchanging cosmos. Instead, it paints a picture of a dynamic and ever-evolving universe, constantly growing and shifting. As the physicist Stephen Hawking once said, the universe is expanding, and if you look at the beginning, you can't help but wonder, is it really expanding, or is it just an illusion? But the expansion of the universe is not just about distant galaxies moving away from each other. It also has a profound impact on our understanding of time and space. The very fabric of space-time is stretched as the universe grows, bending and warping under the influence of gravity. The expansion of the universe means that the distances between galaxies are increasing, but the space between the stars within a galaxy remains relatively constant. This effect is caused by the stretching of space itself, which affects the very way light travels. In fact, the expansion of space causes the light from distant galaxies to shift towards the red end of the spectrum, a phenomenon known as redshift. This provides us with a powerful tool to measure the rate of expansion and understand the underlying dynamics of the universe. As the astronomer Carl Sagan once said, the cosmos is within us. We are made of star stuff, and perhaps in a way the expansion of the universe is our own evolution, ever growing, ever reaching. One of the most intriguing aspects of the universe's expansion is the question of how fast it is expanding. For decades, scientists have tried to measure the rate of expansion, known as the Hubble constant. This value is crucial for understanding the size, age, and future of the universe. However, measuring the rate of expansion has proven to be challenging, as different methods give slightly different results. This discrepancy has become known as the Hubble tension, and it remains one of the greatest mysteries in cosmology. Some scientists believe that new physics, possibly related to dark energy or the properties of the early universe, could help resolve this tension. As the physicist Georges Lemaitre, who first proposed the idea of an expanding universe, once said, "The truth of science lies in the beauty of the theory, and the theory should be such that it can be reconciled with the observable facts." And so, we continue to search for that reconciliation, eager to understand the true nature of the universe's expansion. The idea that the universe is expanding also leads us to a deeper question. How far will this expansion go? Will it continue forever, stretching the universe to its limits? Or will it eventually slow down, stop, and perhaps reverse course? The answer to this question depends on a number of factors, including the amount of matter and energy in the universe. If the universe has enough mass, gravity could eventually slow down the expansion and cause everything to collapse in on itself, leading to a big crunch. On the other hand, if the universe's expansion is driven by dark energy, it could continue accelerating, causing the universe to stretch out endlessly, leaving galaxies to drift farther apart until all that remains is dark, empty space. This possibility is known as the Big Rip, where everything from galaxies to atoms would eventually be torn apart by the accelerating expansion of the universe. As the cosmologist Brian Greene once said, "The universe is expanding, but in a way that we never imagined. And this unimaginable expansion leaves us to wonder where it will all lead. But in all of this expansion, there is a sense of beauty, a sense of awe. The universe, with all its vastness, is still so young, so full of possibility. Even as galaxies drift apart, new ones are being born. Stars continue to form, evolve, and die, leaving behind the elements that make up planets, life, and even ourselves. The expansion of the universe is not just a physical process. It is a process of creation, of transformation. And as we continue to look outward, to explore the farthest reaches of space, we discover that there is always more to learn, more to discover, more to marvel at. As Carl Sagan once said, "Somewhere, something incredible is waiting to be known." And perhaps it is in the expansion of the universe that we will find the answers to the greatest mysteries of existence. The multiverse. Is there more than one universe? As we venture further into the unknown, we encounter a question that seems almost too strange to ask. What if there is not just one universe, but many? What if the universe we know is only one of an infinite number of parallel universes, each with its own laws of physics, its own timeline, its own version of reality? This is the concept of the multiverse, a hypothesis that has captured the imagination of scientists and philosophers alike. It challenges everything we think we know about existence and suggests that the universe we live in might not be the only one. The multiverse is one of the most beautiful ideas in cosmology, said physicist Max Tegmark, and yet it is a concept that may never be fully proven, leaving us to wonder. What if the multiverse is true? The idea of multiple universes is not a new one. It has its roots in the ancient myths and philosophies of many cultures, where parallel worlds and alternate realities were often seen as part of a cosmic order. But it was not until the 20th century, with the advent of modern physics, that the concept began to take on a scientific foundation. In particular, the theory of quantum mechanics has provided some of the most compelling arguments for the multiverse. According to quantum mechanics, every time a decision is made, every time a particle interacts, it splits off into multiple realities, each one representing a different outcome. This is known as the many worlds interpretation of quantum mechanics. As the physicist Hugh Everett, who first proposed the idea, said, "All that is needed is that one set of equations describes everything, everywhere, at all times. And in this framework, multiple universes may be a natural consequence of the quantum world. But even as quantum mechanics suggests the possibility of many worlds, there are other theories of the multiverse that arise from cosmology and string theory. One of the most fascinating ideas is the concept of a bubble multiverse, which proposes that our universe is just one bubble in a vast, infinite sea of bubbles, each one containing its own universe. These bubbles can form through a process known as cosmic inflation, where different regions of space experience different rates of expansion, creating separate pockets of space-time that are disconnected from each other. Each bubble universe could have its own set of physical constants, laws, and even dimensions of space and time. In this view, the multiverse is not a theoretical abstraction, but a physical reality. As the cosmologist Alan Guth, the father of the inflationary universe theory, said, "The multiverse is an inevitable consequence of cosmic inflation, and thus, multiple universes could be the natural outcome of the very structure of the cosmos." Another fascinating idea is the parallel universe theory, which suggests that our universe exists alongside others in the same space, but with different versions of reality. In this scenario, every possible outcome of every event is realized in a different universe, meaning that an infinite number of universes exist, each one slightly or vastly different from our own. Imagine, for example, that in one universe, you made a different decision today. Perhaps you took a different path, met a different person, or chose a different career. In that universe, a whole new timeline has been set into motion, and a different version of you exists, living out that choice. This concept is often referred to as the many worlds interpretation of quantum mechanics. As the philosopher William James once said, "The greatest discovery of any generation is that a human being can alter his life by altering his attitude." And perhaps in another universe, that change has already been made. But how do we test the idea of a multiverse? How do we know if other universes exist, or if we are simply imagining them? The answer is that, right now, we can't. The multiverse theory is, by its very nature, difficult to prove using current scientific methods. Some proponents argue that we may one day be able to detect the effects of other universes on our own, such as through gravitational anomalies or patterns in the cosmic microwave background radiation. Others believe that we might be able to simulate the conditions of other universes in a laboratory setting. But for now, these remain speculative ideas. The challenge of observing the multiverse is that, by definition, other universes are beyond our observable reach. As the philosopher Immanuel Kant once said, "Space and time are the framework within which the mind is constrained to construct its experience." And perhaps we are simply limited by the very nature of our own experience. Despite these challenges, the idea of the multiverse offers a tantalizing possibility, that we are not alone in our universe, that there may be countless others, each with its own history, its own laws of physics, its own version of reality. Some scientists believe that the multiverse could provide a solution to some of the biggest mysteries of the universe, such as the fine-tuning of the physical constants that make life possible. If there are an infinite number of universes, each with different laws of physics, it is not surprising that we happen to live in one that is finely tuned for life. This is known as the anthropic principle, which suggests that the universe must have the properties it does, because if it didn't, we wouldn't be here to observe it. As physicist Brian Greene once said, "The idea of the multiverse adds a sense of beauty to the cosmos. And in that beauty, we find not just scientific discovery, but also a deeper connection to the mystery of existence." The multiverse, in its many forms, remains one of the most profound and mysterious ideas in modern cosmology. Whether it is the idea of multiple universes created by quantum fluctuations, the bubble universes emerging from cosmic inflation, or the parallel universes of quantum mechanics, each possibility challenges our fundamental understanding of reality. The very idea that there may be other worlds, other versions of ourselves, and alternate timelines is enough to spark wonder and contemplation. And yet, the multiverse also raises more questions than it answers, forcing us to confront the limits of our knowledge and the nature of existence itself. As the poet John Keats once wrote, "A thing of beauty is a joy forever," and perhaps the beauty of the multiverse lies not in finding answers, but in the questions it provokes. The simulation theory. Could space be an illusion? As we journey deeper into the realm of possibility, we come to a theory so intriguing, it may seem more like science fiction than science fact. Could the universe we see, the stars we admire, the very space we inhabit, be nothing more than an elaborate simulation, a constructed reality, an illusion? This is the heart of the simulation theory. a concept that has gained traction in recent decades, with some of the brightest minds in science and philosophy pondering the nature of our existence. The idea that everything around us could be simulated by an advanced civilization, or even a powerful computer, challenges everything we think we know about reality. As the philosopher Nick Bostrom, who first proposed the simulation argument, said, "The simulation hypothesis suggests that we are living in a computer-generated world, designed by a far more advanced intelligence. And this thought, in itself, is enough to make us question the very fabric of our universe." The simulation theory, at its core, suggests that what we perceive as reality, the world we touch, the sky we gaze at, the very laws of physics, may all be part of a sophisticated program running in a machine that we can neither see nor comprehend. According to Bostrom's argument, it is possible that a highly advanced civilization could create simulations of consciousness, entire universes filled with sentient beings for the purpose of study, entertainment, or some other reason entirely. In this view, we are not truly alive in the sense that we think, but merely projections of information, operating within a simulated world. As Elon Musk, one of the prominent proponents of this theory, has said, "The odds that we are in base reality are 1 in billions." And this notion leaves us with a lingering question. If our reality is simulated, what is the true nature of existence? One of the key concepts of the simulation theory is the idea of substance dualism. The idea that there is a distinction between the mind and the physical world. If our minds are the product of an artificial simulation, then the physical world around us, including space, time, and matter, could also be part of that simulation. The theory suggests that while our consciousness is real, the universe we experience is only a projection, designed by some higher power or intelligence. This opens up profound questions about the nature of reality and our place within it. Are we merely avatars, playing roles within a program, or are we truly conscious beings with free will? As the famous physicist Albert Einstein once said, "Reality is merely an illusion, albeit a very persistent one, and perhaps this illusion is more complex than we can even imagine." But how would we even begin to test the simulation theory? After all, if we are living in a simulation, we would have no way of detecting it, since the very rules of our world are part of the simulation itself. However, some scientists have suggested that there may be ways to detect glitches in the fabric of our reality, much like a bug in a computer program. These could manifest as inconsistencies in the laws of physics, unexpected behaviors in quantum mechanics, or other anomalies that seem to defy the usual rules of the universe. Some physicists even believe that we may be able to detect the limits of our simulation, the boundaries of the program in which we live. As the philosopher René Descartes once said, "I think, therefore I am." But in a simulated world, would our thoughts truly be our own? Or are they simply pre-programmed responses to external stimuli? Even if we can't detect glitches in our simulated world, the implications of the simulation theory are profound. If we are indeed living in a simulation, it raises questions not just about the nature of reality, but about the nature of the beings who created the simulation. Who or what are the programmers behind our world? Are they benevolent beings watching over us for some greater purpose? Or are we simply subjects in an experiment, like lab rats in a cage? Perhaps the most troubling question is whether we, as conscious beings, have any true free will, or whether everything we experience, every choice we make, is simply part of a pre-programmed script. As the philosopher Jean-Paul Sartre once wrote, "Freedom is what you do with what's been done to you." But if our reality is a simulation, are we truly free? Yet, despite the unsettling nature of the simulation theory, there is also something deeply comforting about it. The idea that space, time, and everything we know are part of a grand design created by an intelligence far beyond our understanding brings a sense of wonder and mystery to our existence. If the simulation theory is true, it suggests that there is a deeper meaning to our lives, even if we don't fully understand it. It also offers a glimpse into the possibility of other simulations, other realities, each one unique, each one crafted by a higher intelligence. This idea of an infinite multiverse of simulated worlds challenges our conventional notions of reality and suggests that there may be countless versions of us, living in different simulated environments, each exploring different aspects of existence. As the writer William Gibson once said, "The future is already here. It's just not very evenly distributed." And perhaps our future is simply another version of the simulation we inhabit now. So, what does this mean for us? What does it mean to live in a simulated world, if indeed we do? Perhaps the most important thing we can take from the simulation theory is a sense of humility and awe. We may not know the true nature of our existence, but we can still explore it with wonder. The fact that we can question the nature of our reality, search for answers, and seek deeper understanding is what makes us uniquely human. And perhaps, in the end, whether we are living in a simulation or in a real universe, it is our ability to question, to seek, and to imagine that makes life meaningful. As the philosopher Socrates once said, "The unexamined life is not worth living." And in that spirit, the search for truth, even if it takes us into the realm of simulation, is what gives our existence purpose. The role of consciousness in space. As we continue our exploration of the universe, we encounter a profound question, a question that challenges the very nature of space and time. What is our place in this vast expanse? How do we, as conscious beings, fit into this endless, ever-expanding universe? Consciousness, our awareness of the world, our thoughts, our feelings, has long been a mystery. It is the lens through which we experience everything, yet its true nature remains elusive. What does it mean to be conscious in a universe that stretches out so infinitely? As the philosopher Alan Watts once said, "You are the universe experiencing itself." And perhaps, in that one statement, we find a key to understanding our connection to the cosmos. Consciousness, as we understand it, is the mind's ability to perceive and reflect upon reality. But what does it mean for consciousness to exist in the context of space? The universe is vast, infinite, and largely indifferent to our existence. And yet, here we are, thinking, feeling, questioning. Is this a random occurrence, or is there something deeply interconnected between the consciousness of living beings and the cosmos itself? Could it be that consciousness is not just something that happens in our minds, but something that is intrinsically woven into the fabric of space itself? In the words of Carl Sagan, "We are made of star stuff. We are a way for the cosmos to know itself." And in that knowing, perhaps we begin to uncover a deeper truth about our existence. One theory that has been gaining traction in recent years is the idea that consciousness is not merely a product of the brain, but a fundamental property of the universe. This is known as panpsychism, the view that consciousness exists at some level in all things, even in atoms, molecules, and galaxies. According to this theory, consciousness is not something we have, but something that is inherent in the very fabric of reality. It is as though the universe itself is aware, and we, as conscious beings, are the means through which the universe reflects upon itself. As philosopher David Chalmers put it, consciousness is not something that comes from matter. It is a fundamental property of the universe. Perhaps in this view, space itself is not empty. but alive with awareness, waiting for us to discover it. This idea of a conscious universe leads us to a thought-provoking question. Does the universe need consciousness to exist? Or is consciousness simply a byproduct of complex systems within the cosmos? Some scientists and philosophers argue that the universe could exist without consciousness, that it is simply a set of laws, forces, and phenomena playing out in an indifferent void. Others, however, suggest that consciousness may be essential for the universe to be experienced at all. If consciousness is truly a fundamental aspect of existence, then perhaps the universe would be incomplete without it. As the renowned physicist Roger Penrose said, consciousness is a central part of the physical world, and we don't yet understand its deep connection to the universe. Perhaps consciousness itself is the thread that ties all of existence together. There is also the possibility that consciousness is intimately connected to the structure of space-time. The theory of quantum consciousness, put forth by physicist Roger Penrose and neuroscientist Stuart Hameroff, proposes that the brain's quantum processes may be linked to the fabric of space-time itself. According to this theory, consciousness may emerge from quantum states in microtubules within neurons, and these quantum states may be influenced by the geometry of space-time. If this theory is correct, it suggests that our awareness could be a manifestation of the very structure of the universe, and that space itself may respond to our consciousness in ways we do not yet fully understand. As the scientist Albert Einstein once said, "The most beautiful thing we can experience is the mysterious." And perhaps it is this mystery that connects us to the cosmos in ways we have yet to uncover. The relationship between consciousness and space raises questions about our ability to understand the true nature of the universe. If our consciousness is inextricably linked to the structure of space-time, then our perceptions of reality may be shaped by the very space in which we live. This suggests that what we experience as reality is not an objective truth, but a subjective experience filtered through our conscious minds. The universe then may not be a static, unchanging entity, but a dynamic process shaped by the minds that perceive it. As the philosopher Immanuel Kant once said, "We see things not as they are, but as we are." Could it be that our perception of space itself is altered by the consciousness that inhabits it? This brings us to the ultimate mystery of consciousness, its connection to time. In the vast expanse of space, time behaves differently depending on where you are. The famous theory of relativity shows us that time slows down as we approach the speed of light, and that time itself can be bent by the presence of mass and gravity. If our consciousness is linked to the fabric of space-time, could it be that time itself is also a product of the mind? As we experience the passage of time, are we simply perceiving the flow of space and events, or are we actively shaping time itself? As physicist and philosopher Thomas Metzinger said, "The experience of time is an illusion created by the brain." And perhaps, in this illusion, we find the deepest connection between consciousness and the cosmos. In the end, the relationship between consciousness and space is one of the greatest mysteries of existence. We know that we are conscious, aware, and experiencing the universe in ways that no other known beings can. But is our consciousness simply a byproduct of the brain, or is it an integral part of the universe itself? As we continue to explore the cosmos, we may find that the boundaries between consciousness and space are not as clear-cut as we once believed. Perhaps in the end, we are not just observers of the universe, but participants in a cosmic dance that binds us to the very fabric of existence. As the poet Walt Whitman once said, "I am large, I contain multitudes." And in that vastness, we are all part of the infinite, interconnected universe. As we reach the end of this journey, we find ourselves in a space of contemplation, a space where questions have been asked, answers have been explored, and the mystery of the universe remains as vast and beautiful as ever. We have ventured through the cosmos, from the origins of space to the concept of infinity, from the expansion of the universe to the possibilities of multiple realities. And yet, as we stand here, gazing into the endless expanse, we realize that the most profound truth may not lie in finding answers, but in embracing the mystery itself. As the philosopher Rainer Maria Rilke once said, "The point of life is to find out what is the meaning of life." Perhaps in the vastness of space, we find that the meaning is not something to be discovered, but something to be experienced. The more we learn about the universe, the more we realize how little we truly know. The mysteries of space seem to multiply as we peel back the layers of the cosmos. For every discovery we make, new questions arise. Questions that stretch beyond the boundaries of our current understanding. And yet, in this endless search for answers, we find beauty. Beauty in the vastness, in the questions themselves, in the fact that we are part of this grand, infinite process of exploration. As Carl Sagan once said, "The cosmos is within us. We are made of star stuff." And perhaps that is the most profound lesson of all, that we are connected to the very fabric of the universe, part of its eternal mystery, and that our curiosity, our questions, are what drive us forward. While we may never fully understand the nature of space, time, and the universe, there is a certain peace in accepting the mystery. Space, with its vast emptiness and boundless possibilities, mirrors the mysteries within our own lives. There are no clear answers, no neat conclusions. But that is where the beauty lies, in the exploration, the questioning, the wonder. The universe is not just a place of stars and galaxies, but a reflection of our own curiosity and search for meaning. As the philosopher Socrates said, "The unexamined life is not worth living." Perhaps this is true of the universe as well. It is in the examination, in the seeking, that we find the richness of existence. Perhaps the most profound realization of all is that space itself is not just a physical entity. It is a reflection of our own quest for knowledge and understanding. The universe is a mirror, reflecting our desire to explore, to ask, to discover. And while we may never reach the final frontier of knowledge, the pursuit of answers is what makes life and the universe so beautiful. Our curiosity, our drive to understand, is what propels us into the unknown. It reminds us that we are not passive observers of the cosmos, but active participants in the grand story of existence. As the poet John Keats once wrote, "A thing of beauty is a joy forever." And perhaps the beauty of the universe is not in its answers, but in the endless questions that keep us searching. In the end, space is more than just the stars and galaxies we see in the night sky. It is a metaphor for the human experience, vast, mysterious, and filled with wonder. As we gaze into the cosmos, we are reminded of our own smallness, our fragility, and yet our potential for discovery and growth. Just as space stretches infinitely outward, so too does our capacity to wonder, to imagine, and to seek. We are part of the universe, made of the same star stuff, and connected to everything that has ever existed and will ever exist. The universe, in all its vastness, is both our home and our mystery, a place where we can explore not just the cosmos, but also the depths of our own consciousness. As the poet Walt Whitman said, "I am large, I contain multitudes." And in that multitudes, we find the universe within ourselves. So, as we bring this journey to a close, I invite you to embrace the mystery of space, to let it fill you with wonder, curiosity, and peace. Whether you believe space is infinite or finite, or even a simulation. The one thing we can all agree on is that it is a source of endless inspiration. In the pursuit of understanding, we grow, we learn, and we become part of something much greater than ourselves. The universe, in all its complexity, is not something to fear, but something to explore with awe and humility. As the scientist and explorer Neil Armstrong once said, "That's one small step for man, one giant leap for mankind." And each of us, in our own way, takes a small step forward into the unknown, asking questions, seeking answers, and embracing the beauty of the mystery that is space.